Okay, welcome to the test 2.1 review, and we will go through this question by question. All work will be shown by hand. Everything will be explained to you so you're prepared for your test. Okay, now on numbers 15 and 16, we'll make use of some technology. I don't have the ability to emulate the TI Inspire installed on this computer, so we'll use MathWave for that, but I'll show you that when we get to it. And now for number 1, solve using substitution. So whenever you see a variable sitting by itself, like this y is sitting by itself, I automatically want to use that equation to isolate the y variable. And the way I'm going to do that is by subtracting 5x from both sides of the equation. Okay. And I want to get my ruler and make that a 90-degree angle. Unbelievable. There. Okay. And let's get we want a guideline here. So, remember, the equation must always remain in balance. So I subtracted 5x on the left, which gives 0. So you can think of this subtraction produces 0, but we usually just mark it out. And now y is the only remaining term, so y equals, and you always list the variable term first. So the coefficient is -5, the variable is x, and then we have plus 15. Okay. So y equals -5x plus 15. Okay? Well, now what do we do with that? Well, let's just say it back again. We just said y equals -5x plus 15, so I can plug that y right there. Okay? That's what substitution means. I'm going to substitute, right? This for that. Okay, so let's do that now. We're going to perform the substitution now. So we'll do -4x minus 3. Let me get rid of this line for a second. And now what I'm going to do is do a big open parentheses. And inside that parentheses, I'm going to put -5x plus 15. -5x plus 15. Now, by student request, I won't do any tricky mathematics here. I'll just do it the normal way, and that's equal to -12. Okay. So far, so good. Let's get our new guideline. Right, there we go. And so, as I said, I'm not going to do any tricky, fancy, weird mathematics. Just note that what you've really got here, I feel like I need to write this out. You've really got here is you've got -4x plus, okay, and then you've got -3 multiplied by -5x plus 15. Okay, it's very important that you understand. You don't have to write it that way, but it's very important that you understand that that's a -3 and it's being multiplied by this binomial. And so what we have to do is distribute the -3 into the binomial. Okay, so that's distributed multiplication. So we do -4x plus, okay, and then -3 times -5x is 15x, and -3 times 15 is -45. Okay, line up those equal signs, keep them aligned, and we have -12 on the right. It's just an interesting note. This equation is currently in balance. That means that that whole negative 12 is holding up the balance of the entire left side. So that's kind of cool. I see some like terms. I see a negative 4x and a positive 15x. Those can be combined, right? So we'll make sure to do that. But first, I think, and you know, there's 1,000 ways that you could do this. I'm just going to go ahead and add 45 to both sides so that I get my numbers on the right. Why not, right? So again, that would add to be 0, but we just cross it out for simplicity's sake. And so now I'm basically subtracting 4 from 15, which gives me 11. So I have now on the left side 11x, okay, equals, and now I have 45 minus 12. That's really what negative 12 plus 45 means. So that's 3 and 3, 33. Okay, and now we will divide both sides by the coefficient of the x variable. Okay, so I'm going to divide by 11 and divide by 11. Okay, now why would I do that? Well, the primary reason is I can now cancel the 11s on the left and have x equal to 33 divided by 11. 11 is a factor of 33, and its cofactor is 3, so x equals 3. Now that I know x equals 3, I can now substitute yet again into either equation. So the easier one is the bottom equation, so we'll just continue. Okay. Now what we're going to do is sub 3 FOR x in 5x plus y equals 15. Okay, so that's what I'm going to do. So I'll write 5 and then open parentheses 3 close parentheses plus y equals 15. And 5 times 3 is 15. So right now I already know that the answer is going to be y equals 0, and I'll show you why I know that. So if you ever find yourself in this situation, you can kind of jump to a conclusion. You have 15 plus something equals 15. Well, the only thing that something could be is 0, because 15 plus anything else would not equal 15. Okay, so that's how I know. Now I'll go ahead and show the math. We would subtract 15 from both sides. But I want you to kind of think about it, right? What could it possibly be other than 0, right? So y's value is 0. Now we combine the fact that we know x equals 3 and the fact that we know y equals 0 into our solution, which is going to be in the form of x comma y, right? And our solution here is going to be 3 comma 0. Okay? And that's where those two lines would intersect if graphed. Just keep that in mind. Okay? With that in mind, that is the end of number 1. All right, students, here we are with number 2. So same thing, we're going to perform substitution, and what we want to do here is isolate one of the variables and substitute it in to the other equation. Okay, so it looks like y is by itself here on the second equation, so that would be the easier one to isolate, the easier variable to isolate. So we'll go ahead and do that. Let's select some color. I try to choose different colors. Let's find something we haven't used a lot of. Some kind of green here. All right, so we would plus 3x. And we got to keep our scale balanced, so we're going to plus 3x here. and then I'm going to drop that little guide mark to keep everything nice and orderly. And we know this sums to 0, 3x and negative 3x, but we'll just mark it out. And we've isolated y equals, remember, go this first, always that first, just stylistically, 3x plus 8. Now 8 plus 3x is still valid, it's just not how it's normally written. So now what we want to do is substitute this algebraic expression right here for this y. We're going to plug that in. So let's do that now here in this kind of second phase of the process. So let's say we're going to substitute 3x plus 8 for y in negative 6x plus 2y equals 4. Right, that's what we're gonna do right now. So we're gonna write negative 6x plus 2, and then open parentheses, and then we're going to put in 3x plus 8, close parentheses, equals 4. Okay? And this one's a little bit easier to understand, that we're distribute multiplying a positive 2 to both of these terms. Okay? So let's drop a new ruler here. And let's see what we get. We got that negative 6x plus 6x plus 16 equals 4. Well, I noticed something here. I noticed that I've got a negative 6x and a positive 6x, so those are going to cancel out with one another. And now I've got this truth claim, 16 equals 4. Okay, and this is what we call a false equivalence. So that's not true, right? False equivalence and what that means is that there's no solution. So there's a couple things that it means. It means that there's no solution. Yeah, that's the thing that you'll write for your test, but it also means something else that you might not know. It means that the lines are parallel, okay, to one another. And that means a third thing that you can also abstract from this finding, which is kind of interesting. It means that they have the same slope. Okay, because parallel lines have the same slope. So we know quite a bit about these lines, even though we've determined that the actual answer to the question, the thing that you would want to put on the test, is no solution. Okay, but it's interesting to know that that doesn't mean you've learned nothing about the lines. So they never cross, which means they're parallel in a Euclidean space. Euclidean meaning two-dimensional flat land. They would never cross. When you get up in higher mathematics and you learn about non-Euclidean geometry, you find out that doesn't always hold. A very good example of when two lines with the same slope do cross is the globe, lines of longitude. If I can draw a circle here, lines of longitude do something like this, right? Right? That you see this on a globe. They all start at the North Pole and they terminate at the South Pole. And so you can see that in a non-Euclidean space, this is a sphere here, okay, that the lines would cross. But we are living in this algebra. We are living in what we'll call flatland. Okay, that would be a space like this, where parallel lines they don't curve. In other words, there's no curve to them. So in a Euclidean space, those lines will never cross because they have the same slope. Okay, so just look forward to that as you get older and go into math more. This is non-Euclidean, right? And this is Euclidean. Euclidean referring to Euclid, right? So, all right, that's the end of number 2. All right, students, here we are on number 3. So again, we're substituting, so we'll just do the bottom one here. We've got, let's add x to both sides, and then we'll have, get our guide mark in there. We'll have these cancel out, leaving negative 2y equals x minus 6. And now I have to divide everything by negative 2. Okay, so I'll divide everything by negative 2. Just like that. Okay, now at this point it's very important to remember there's a 1 right there, and that negative sign goes with the 6. Okay, so just to avoid confusion. So now I have y equals, and what I'm going to do is I'm going to write negative 1 over 2 out in front like its own fraction, like this, and then put the x here so it looks more like the slope-intercept form. And then negative 6 divided by negative 2 is positive 3, so plus 3. So that's what I found y is, and now I can substitute that into my other equation. And so what we're going to do now is we're going to negative 1 over 2x plus 3 for y in negative x plus y equals 9. Okay, so that's what that means. We're going to do negative x plus, okay, open parentheses, and then we're going to put negative 1 over 2x plus 3, close parentheses, and equals 9. Okay, and so there's nothing to distribute here. We just have to solve. So let's get our guide mark going. And we just drop the parentheses, negative x minus 1 over 2x plus 3 equals 9. Okay, so we can't combine these yet because we need to do a little side work and say that negative x is really equal to negative 1x over 1. Okay, and so if I multiply that by 2 over 2, then I'll have a denominator of 2. Okay, that will equal negative 2x over 2. All right, so I'm now going to substitute this for this. Okay, so now I have negative 2x over 2 minus 1 x over 2. You see that? I've changed now the form so that you can see the common denominator property there. Plus 3 equals 9. And so the only reason we're able to combine these terms now is because they have that common denominator. So we're going to combine these terms. So negative 2x over 2 minus 1x over 2 is identical to saying like this, negative 2 minus 1x over 2. Okay, so negative 2 minus 1 is negative 3. We'll get there. Plus 3 equals 9. So now I've got negative 3 over 2x plus 3 equals 9. Subtract 3 from both sides. And I have negative 3 over 2x equals 6. And what I want to do is multiply by the reciprocal, which would be negative 2 over 3 on both sides. And it's helpful to remember here that that's 6 over 1. Okay, cancel, 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 cancel. And I now have x by itself equal to negative 6 times negative 2 is negative 12 over 3, which reduces down to x equals negative 4. Okay, so x is negative 4. Now, what I want to do is substitute that back into either of my equations. We'll use the top one. Negative x plus y equals 9. So we'll say here, if x equals negative 4 and negative x plus y equals 9, right? Isn't that what it says? Yep. So you'll say if then, right? Then negative 4 plus y equals 9, which means 4 plus y equals 9, and we subtract 4 from both sides, and we get y equals 5. So y equals 5 and x equals negative 4. Anybody tell me what quadrant that is in? Where is x negative and y positive? It would be quadrant 2, right? So x comma y, we got negative 4 comma 5. Okay, and that's going to be your solution there to the problem. Alrighty. And that is the end of number 3. Here we are on number 4. The top equation is going to be way easier to solve for. So let's just write this out. X plus 7y equals negative 6. All we have to do is subtract 7y from both sides. And we've got x by itself. So x equals negative 7y minus 6. So now that we know that, we can substitute that back into this bottom equation here. And we can say that we're going to sub negative 7y minus 6 FORX 4x in 3x plus 6y equals negative 3. Okay, so let's go ahead and do that. 3 open parentheses, and now let's put what we found, negative 7y minus 6 close parentheses, and then we write plus 6y equals negative 3. Okay, some distribution time. We're going to distribute the 3. And we're going to write down negative 21y minus 18 plus 6y equals negative 3. Okay. And what do we do now? Well, we can add 18 to both sides. Okay. And now that gives us negative 21y plus 6y, those can be combined, equals positive 15. Okay, so what's 21 minus 6? 15y. So now I've got negative 15y equals 15. Should be fairly obvious what we're going to do next. We're going to divide both sides by negative 15. Okay, and we have y equals negative 1. Okay, so now that we know that, we can plug that into either equation. Let's do the top one. X plus 7y equals negative 6. So we can say something like, if x plus 7y equals negative 6 and y equals negative 1, then the following, right? Then x plus 7 times negative 1 equals negative 6. We're making a claim to truth here. So we have x minus 7 equals negative 6 plus 7 plus 7, and we have x equals 1. Okay, so we have x equals 1, y equals negative 1. In what quadrant is x positive and y negative? Okay, so the solution x comma y is going to be 1 comma negative 1. What quadrant is that in? Where is x positive and y negative? This would be Q4. Okay, just for trivia. Alrighty, and that brings us to the end of number 4, and I believe brings us to the end of substitution, which is always quite a challenge. So good job on completing number 4. Okay, so we've now reached the end of the section on substitution. We've solved 4 problems using substitution, and I wish we'd encountered one where it was all real numbers, but we did find one with no solution, which gave me a reason to talk about non-Euclidean geometry. The next section focuses on elimination, and then we move on to graphing, and then we move on to some verbal problems or word problems, and finally matrices, which we will use a calculator to help us with. But we are now done with section 1 of the test review, substitution. All right, here we are on number 5, where we're asked to solve each system using elimination. Okay, so now what elimination requires us to do is to make one of these numbers, or one of these coefficients, the same on the top and the bottom. And most people can quickly see that if I multiply the bottom number by, let's try to do this in such a way that we can just add the columns, right? So I would love for this right here to become a positive 14. Now how would I do that? Well, I'd multiply everything by negative 2. Okay, so if I do that and I distribute that here, and all the way over here, okay, look what I'm going to get. I'm going to get 18x plus 14y equals 50, positive 50. Now just write the the top equation underneath this one. 4x minus 14y equals negative 6. And what we're going to do is we're going to do elimination by addition. This is by far the easier of the two to do, because we don't have to distribute that subtraction symbol all the time. Okay? So remember, when we do this, we like to think of ourselves as working in columns. So there's a column and there's a column. And so let's get to work. So we're adding 18 plus 4 is 22x. And now I've got these canceling out. And then the equal sign, 50 minus 6 is 44. And so I see a nice solution coming here. If I divide both sides by 22, I think that's going to work just very nicely. I'll have x equals 2. Since 2 times 22 is 44, 44 divided by 22 is just 2. Okay. So we found out that x equals 2. And now we are going to, it's like elimination, you're still going to substitute, but you're just going to plug in 2 for one of these. Let's use the top one. So what we're going to say is, we're going to say, well, if x equals 2, then 4 times 2 minus 14y equals negative 6. Okay, so that's that we just plugged it in there, and now we're going to solve for y here. Okay, so I've got 4 times 2 is 8 minus 14y equals negative 6. Let's switch it up a little bit. And so now I'm going to subtract 8 from both sides. And now I've got negative 14y equals negative 14. Okay, so y is going to equal 1, because we're now going to divide both the left and the right side by negative 14. Negative 14, cancel, cancel, and y equals 1. Okay, y equals 1. So in what quadrant are both x and y positive? Quadrant 1, right? Top right. So x comma y, we have 2 comma 1. That's where those lines intersect. All right, that is the answer to number 5. Okay, so here we are on number 6. And I think it'd be fairly easy to get. Let's see if we can do it, right? We want the bottom one. Let's make this negative 2 into a positive 6. What would we do? Well, we would multiply the entire equation by something that would turn that negative 2 into a positive 6, which would be a negative 3. Right? That would be the ideal situation, and then we could just add, right? So we're going to distribute that to all the terms in the bottom equation. Okay, so we're going to have to rewrite all of this now. So we're going to rewrite, we're going to write, let's see, negative 3 times negative 2x, that's 6x plus 36y equals 60. Okay. Then we have negative 6x minus 6y equals 0. Okay, well, let's get our ruler going here. Well, what should we do first? Should cancel that out. Those eliminate. And all that's left to do is add 36 and negative 6, so that's 30y equals 60. And so if I divide both sides by 30, I get access to y very easily. Y equals 2. So now that we know y equals 2, we can plug it into one of the equations, and I suppose it doesn't matter which one. So we'll say negative 6x, we're doing the top one. Okay, this is the top equation. Negative 6x minus 6 times 2 equals 0. Alright? So I have negative 6x minus 8 equals 0. I'm going to add 8 to both sides. And I have negative 6x equals 8. And this one's not going to result in an integer solution, but that's okay. So we're going to divide both sides by negative 6. Cancel, cancel. And we have x equals what? Divide top and bottom by 2, right? And what do we get? 4 over 3, negative 4/3. So that's my solution here, x comma y. I've got negative 4/3 comma 2. Okay, and that is the answer to number 6. Well, here we are on number 7. Looks like we need to multiply the top equation by negative 2, and that way we can eliminate these, right? Multiplying by negative 2, that'll make that positive 18, then I can just stack, add, get it all over with. So we're going to need to rewrite a bunch of this stuff. So I've got to actually rewrite everything. I'm going to write, what was I going to multiply by? Negative 2, yeah. So I'm going to write negative 2 out here, times, and then I'll put this whole thing in parentheses, 3x minus 9y, okay, equals 24. Sorry, I put that parentheses too soon. I'm actually going to distribute that negative 2 to every term, including the 24, which I often forget. So now I have negative 6x plus 18y equals negative 48. Okay, so let's put the other thing underneath it. We've got negative 5x minus 18y equals 26. Okay, and so now it's time to stack add. Right? So we're doing elimination by addition, and this cancels. So now just add negative 6, negative 5, that's going to be negative 11x. And what's negative 48 plus 26? Well, it's basically a subtraction problem. The answer is going to be negative. So 8 minus 6 is 2. 4 minus 2 is 2, and it's negative. So we have negative 11x equals negative 22. So I'm going to divide both by negative 11. Cancel, cancel. Right? So x equals, be careful here, what am I doing? Positive 2. Alright, so now I know that x equals positive 2. Okay. Where should we plug this in? Top one? Yeah, less negative symbols, I'm guessing. So I'm going to write 3, open parentheses, 2 minus 9y equals 24. 6 minus 9y equals 24. Minus 6 on both sides. Negative 9y equals 18. Divide both sides by negative 9. And you get y equals negative 2. So I've got y equals negative 2 and x equals positive 2. What quadrant is that in? Where x is positive and y is negative. going to be Q4, right? It's the only place where x is positive and y is negative. All right, and that is the end of number 7. Okay, here we are with number 8. Well, this is an interesting one because I think we're finally going to get an all real numbers, maybe. If I multiply everything by -4 on the top, watch what happens. Okay, so I'm going to multiply everything by -4. It's -1x minus 1y equals -1. And I'm going to multiply. A student in class used the right term. They said multiply by a scalar. It's a perfect use of that academic language. We get 4x plus 4y equals positive 4. Well, the other equation is 4x plus 4y equals 4. So these are the same equation, right? When I, let's say I was going to do elimination by subtraction, right? So I was going to subtract 4 minus 4x cancels, 4y minus 4y cancels, and 4 minus 4 cancels, leaving 0 equals 0. And that's true, okay? That's a true statement. So since it's true, it means it's all real numbers. And the important thing to take away is that it's the same line, right? You really need to know that it's the same line. And it's fantastic. I'm glad we finally got one. All right, that was number 8. And I believe that brings us to the end of the section on elimination. All right, so good job on finishing number 8. Okay, here in number 9, we're in a completely new section. We're asked to solve each equation by graphing. Now, I find that many students just do not understand equations that look like this. Okay, there are 2 weird situations. Weird situation number 1 is y equals some number, okay? The other weird situation is x equals some number, all right? Now, here's what you need to know. In this situation, you're going to have a horizontal line. And in this situation, you're going to have a vertical line. So the situation we're dealing with here is that horizontal line situation. The y-intercept is 2, so you're going to draw a horizontal line passing through 2. Okay, so there's your first equation, and we always want to label it. So this is y equals 2. Now we're going to plot this one. So quick review, that's the rise. That's the run, and -1 is the y-intercept. So when I start to plot this, I want to go to the y-intercept at -1 and put a little dot. And then what I want to do is go up 3 over 2. So up 1, up 2, up 3 over 1 over 2 right here. So that's my point of intersection. That's the solution at that coordinate right there. But let's go ahead and draw the line. Okay, bingo. We drew the line, and we'll label it. This is y equals 3/2 x minus 1. Okay, well, what is the answer to the question? It's right here. It's this coordinate right here. Remember x comma y, so you want to make some kind of mark like this and say, the solution is 2, 2. Okay, and that's it. That's number 9. That's how you do it. Okay, number 10 presents us with a challenge because we have to get the equations into y equals form in order to graph them. So they're both in what's called standard form right now. And so we would need to get y by itself. So let's take the top equation first. So we'll do the top equation first. Since we have to do this for both of them, we got x minus 2y equals 4. Subtract x from both sides. You got negative 2y equals negative 1x. I'm preparing for something by doing that, plus 4. And now I'm going to divide by negative 2, divide by negative 2, divide by negative 2. So y equals 1 over 2x minus 2. Okay, so now I've got that in slope-intercept form. And so now we'll do the bottom equation. And that was x plus 2y equals negative 8. And I'll subtract x from both sides. And I'll have 2y equals negative 1x minus 8. And divide everything by 2. Divide by 2. Divide by 2. Okay, cancel, cancel. Y equals negative 1 over 2x minus 4. Okay, so now we're going to plot both of these lines here. Okay, so we'll start with the top one. And I will plot here. Equation 1 here starts at negative 2 and then goes up 1 over 2. Up 1 over 2, like that. Let's draw that in. There we go. There's that line. And that's y equals 1/2 x minus 2. Now we'll draw the other one, which starts at negative 4. And it has a down 1 over 2. And so we can go up 1 to the left 2, up 1 to the left 2. So we can get a line. We can kind of do the rise over run in reverse. When the slope is negative, it's not really the rise over the run, it's more the fall over the run, right? So we draw the line, and we see that intersection point there is going to be our answer, right? This point right here, that's the solution. So let's find a place to write it, maybe up here. That coordinate is negative 2 on the x, comma, negative 3 on the y. Alrighty, and that is the end of number 10. Well, here we are on number 11. So we've got to do the same thing. I've got to rewrite. There's no room to do that over here, so I'm going to do it down below. First, we'll take the top equation, and we got 3x plus 4y equals 8. And we will subtract 3x from both sides. And I've got 4y equals negative 3x plus 8. Okay, well, I'm going to divide everything by 4. And I have y equals negative 3 over 4x plus 2. Okay, so that was one of my equations, and now my second equation. This is the bottom equation. And that was x minus 4y equals 8. All All right, so, and I like to put the 1 here. Okay, so we'll subtract 1x from both sides. And that gives me negative 4y equals negative 1x plus 8. And now I'm going to divide everything by negative 4. Negative 4, negative 4. Okay. So y equals 1 over 4x minus 2. So now I've got my two equations. I can plot them. And so we'll plot the green one in green, start at the y-intercept of 2, and then go down 3 over 4. Okay? Start at the y-intercept of 2, and then go down 3 over 4. All right? We can start at the y-intercept of 2 and go up 3 over 4 as well. To get a second point, let's all line up like that. Okay, there we go. And let's label that equation y equals negative 3 over 4x plus 2. Okay, second equation, y equals 1/4 x minus 2. All right, this is minus 2, and then up 1 over 4. Bingo, there's the intersection point. Down 1 over 4 gives us another point to help us plot this in. Okay, and we see that intersection point right there. Right there is the solution, and that's going to be at 4 on the x and negative 1 on the y. Okay, so that is number 11 right there. Good job on number 11. Okay, here we are on number 12. So I think I can do it off to the side here. I've got the top equation, negative y plus 1 equals x. Well, subtract 1 from both sides. And now I've got negative y equals x minus 1. Quick trick, just change all the signs. Y equals negative x plus 1. Okay, so that's the top equation. Now the bottom equation, it's a little bit weird. We've got 4 equals negative 2x plus y. Let's go ahead and solve for y on the right by adding 2x to both sides, because then we're done. And we'll use the reflective property of equality to say y equals 2x plus 4. So those are my two equations. Let's get to plotting. I've got here this top equation, y-intercept at 1, down 1 over 1. So it's going to be like this. And then we'll draw that in. Okay. And that is y equals negative x plus 1. Okay. Now let's do the bottom equation. Plus 4, and that's up 2 over 1. So we can't do that because we run out of grid. So we go down 2 to the left 1. Down 2 to the left 1. Okay. So you just kind of reverse that rise over run. You go down and to the left instead of up and to the right. Yeah. Okay. So we already see where it's going to cross. Right there. Let's go ahead and draw the line all the way in. And make sure you label that line y equals 2x plus 4. Okay? And so we've identified the solution to the system at the point of intersection of those two lines, which is actually right here. And that point of intersection is on the x is negative 1, and on the y it's 2, so it's negative 1 comma 2 as the solution to number 12. And that brings us to the conclusion of the graphing portion of the review. Very good job completing not only number 12, but the graphing portion of the review. All right, now we're on to everybody's favorite thing, which is word problem. Oh no, that's everybody's least favorite thing. Mine too. Unfortunately, the real world is one massive word problem, so getting good at this will help you. Okay, Arjun and Matt are selling wrapping paper for a school fundraiser. Customers can buy rolls of plain wrapping paper. Okay, now right away, what you need to start doing is identifying words and assigning them a variable. Okay, so we're going to assign plain wrapping paper the variable x, and rolls of shiny wrapping paper. Okay, well let's assign shining wrapping paper the variable y. Okay, that makes sense. So we're going to assign that y. So it says Arjun sold 6 rolls of plain wrapping paper, or 6x, and 6 rolls of shining wrapping paper, 6y, for a total of 22 equals 22. So let's write this down. We've got 6x plus 6y for a total of 72, so equals 72. And then it says Matt sold 12 rolls of plain wrapping paper, so that's going to be 12x, and 5 rolls of shiny paper plus 5y equals, how much did he make? $88, so equals 88. And basically it wants us to find the cost of each and blah, blah, blah. Don't worry about that. All you want to do is solve for x and y, ladies and gentlemen. So we can do this using elimination very easily by multiplying the top equation by -2. And if I do that, I'll be able to simply stack add and get rid of the x altogether. So let's go ahead and distribute that -2, and we'll see what that becomes. We kind of have to work horizontally here. So we're distributing the -2 to all the terms in the top equation. So that's going to give me -12x minus 12y equals 72 times 2. If you don't know it, multiply it and make the result negative. So 2 times 2 is 4, 7 times 2 is 14. So that's -144. Okay. So don't worry about all this being negative. We don't care anymore. We're just trying to eliminate the variables. And now you just put the other equation right underneath it. You have 12x. You see we're going to be able to add and get rid of that the x. -12x, positive 12x goes away. And we got plus 5y equals 88. Alrighty. So now let's get that ruler out, or your protractor, which I know all of you carry everywhere with you all the time. And let's stack add. Okay. Bingo. Got to eliminate the x variable. So now -12 plus 5 on the y is going to give us -7y equals -144 plus 88. So it's basically a subtraction problem, and the result is going to be a negative number, okay, because the number with a larger magnitude is negative. So we can't take 8 from 4, so we have to borrow. Well, we can't take 8 from this, can't we? But this is 0, and this becomes a 13. and this becomes a 14. Okay, and so now I can take 8 from 14, and that gives me 6. I'm subtracting. Sorry, don't want to confuse anybody. I'm subtracting. So 8 from 14 gives me 6, and then 8 from 13 gives me 5, and 0. Okay, this is going to be negative 56. All right, so now all we have to do is divide both sides by negative 7, and we will have arrived at y. Y equals 8. Okay, so 8 shiny wrapping paper. I guess the cost of one roll of shiny wrapping paper is $8, right? So I don't know what they want from you, but you could say with finality, the cost of one roll of shiny, we'll just say shiny, is $8. Okay, kind of expensive, but whatever. All right, so now we were going to plug that 8 back into one of our original equations to find out what the other variable is. Okay, we're going to find out what x is. So somehow I erased the what was here, and that was 6. So put that back. This was 6y. Okay, so we're going to go ahead and into this original equation right here, plug in y equals 8. So we're going to plug in right there the 8. All right, you can almost do it in your head, but of course we'll show our work because that's what we're all about. So here's where we're going to find out how much the plain wrapping paper cost. All right, so now that we know that y equals 8, we're just going to plug that 8 back in, okay, to one of the original equations. So we'll plug it in here, okay. So what we're going to write over here is we're going to write 6x plus 6, open parentheses, 8 equals 72. So we have 6x plus 48 equals 72, minus 48 on both sides. We have 6x equals 72 minus 48. Well, we can't take 8 from 2, so we have to borrow and make this a 6, and this a 12, and this is a 4, and this is a 2. And then we just divide both sides by 6, giving us x equals 4. In other words, the cost of plain paper is $4. Okay, so half the price of the shiny paper. Okay, and that is the end of number 13. All right, here we are on number 14. Gabriella and Jose are selling cookie dough for a school fundraiser. Customers can buy packages of chocolate chip cookie dough. So here we want to highlight this and give it a variable name. We'll give it variable name x. And gingerbread cookie dough. So we'll give that the variable name y. Okay. And once we get this going, we can just write down our equations. So it says here Gabriella sold 9 packages of chocolate chip cookie dough, which we have labeled x, so it's 9x, and, which is plus, 1 package of gingerbread cookie dough, which we labeled y. Okay, for a total of $70, in other words, equals 70. Okay, and that's how you form these equations. And then Jose sold 3 packages of cookie dough, 3x, and 2 packages of gingerbread, 2y, for a total of 50 equals 50. All right, so there's your 2 simultaneous equations. All right, so now they want you to solve for x and y. Find the cost of chocolate chip, which is x, and cost of gingerbread, which is y. All right, so We're going to do this using elimination. And the best way to do it is to multiply the bottom equation by negative 3. And the reason I'm saying negative 3 is if I multiply the bottom equation by negative 3, then the first term will become negative 9x, and then I can just stack add and eliminate the x variable. So I'm going to multiply the bottom equation by negative 3. And remember, I'm not going to, I have to do this kind of like horizontal mode, so you understand I'm distributing the negative 3 to all terms, including that 50. Okay, so let's rewrite it. That's going to be negative 9x. And then minus 6y. And remember, we call this a scalar. And then that would be negative 150. Okay. Now above it, we just write the original. 9x plus 1y equals 70. And now we're ready to stack add. Okay. And that's the beauty of using the elimination method, especially when you can add and eliminate. It's super easy because that cancels. And now we do 1y plus negative 6y, that's negative 5y. So negative 5y equals, and then you do, you got 70 plus negative 150, which is just a subtraction problem, 150 minus 70. And that's going to be 80. Okay, negative 80, right? So we put negative 5y equals negative 80. Now, divide both sides by negative 5. Cancel, cancel. 5 goes into 8 one times with 3 as a remainder, so the next term would be 6, so you have 16. It's a negative over a negative, so the result is positive. Therefore, y equals 16. Okay, so y equals 16. Now that we know y equals 16, we can plug it back into the top equation, or any equation, but this one has a 1y in it, so you might as well use the easy one. 9x plus 1 times 16 equals 70. Okay, so 9x plus 16 equals 70. And we'll subtract 16 from both sides. Again, that's really small. So 9x equals 54. Therefore, divide both sides by 9. You got x equals 6. So what does that mean? It means that we'll just abbreviate chocolate chip cookie dough costs $6. Right? Remember, it's money. And then gingerbread cookie dough costs $16. Okay, and that's the answer. All right, so you got that done. Put a little box around it. And that is number 14. All right, so now we're on to number 15 and 16, which are the matrix problems. So this is super exciting because who doesn't love that movie? You remember, they are coming out with a new one, so if we had more time to study matrices, we would definitely have to watch the trilogy in class so we could be prepared for the upcoming 4th installment. But let's start our journey with number 15. Now, what it tells you to do, it says write the system of equations and solve for each variable, then create a matrix. So, you know, we don't get to have all the fun. They don't want us to actually use Gaussian elimination or reduce, the reduced row echelon form that we learned in class. We're going to just write down the matrix, okay? So the way that you represent this is you kind of do the same thing we did in the word problems above, except you're going to have x, y, and z. So let's say the candles are your x. All right, let's match the colors with this highlighter. So that's the x, and then your soaps are the y. We'll make that green. Okay, and then your hand sanitizers are going to be the blue. Okay, so we'll make that blue. And that's going to be Z. Okay, so if you're going to create your equations, you'll write 3x plus 3y plus 5z equals $6. Wow. 6. Okay. This is very cheap. Okay. I mean, remember above here we had cookie dough costing $16. Down here you can buy all this stuff for $6. All right. Well, anyway, next line, it tells you you got 4 candles. Remember, candles are x, so 4x plus 4y for soap plus 4z for hand sanitizer for a total of $18. Okay, so that's equals 18. And then your final equation here is going to be 4 candles, so 4x plus 2 soaps, 2y, plus 1 hand sanitizer, 1z equals 16. So they want us to solve this system of 3 linear equations, but they want us to use technology. So don't worry, we're not going to have to actually do any real work, even though it wouldn't be all that hard to do. We're going to use technology, and I'll just leave it there. Okay, so let's assume that we use the technology, and I'll show you how we use the technology in a second, but we're going to go ahead and write the matrix. And now look, this is really easy. So you just strip out the letters, okay? So like here, let's use the right color. So now think about it as columns and rows, right? So we care about the 3, the 4, and the 4, and that's going to be one column. And then we care about the 3, the 4, and the 2, and that's going to be another column. And then we care about the hand sanitizers in 5, 4, 1. And then this is going to be what's called an augmented matrix, which will require us to draw that line. And let's give this some color here. We care about these numbers as well. Okay, so in order to turn this system of 3 variable, 3 equation, 3 variable into a matrix, all you do is basically just draw this big open bracket looking thing and then write 3, 4, 4. Remember, the column is a vector. They're all x, so that's a vector. And then you have 3, 4, 2. All right, and then you have 5, 4, 1. And then you have your augment line, which just means like where the equal sign went in the equations above, you draw this bar, okay? And then you write down 6, 18, 16. And then you close that sucker off with the closing bracket. Now that right there is something we would use Gaussian elimination. We would try to create something called, so I'll get into it later, but it's something we call a triangular identity. Basically, we would want to make these numbers be 1s and all these other numbers here be 0s. Okay, and if we could do that, then we would know that z equals some number, y equals some number, and x equals some number. And that's how you actually do that. But we're going to use technology to solve the system. All right, so we wrote down the matrix. Now let's solve the system. How are we going to do it? Well, we're going to cheat because I don't have the TI Inspire. What I'm going to do instead is go to Mathway. And I know none of you have ever been to this website before. So this will be a new experience for all of you. Okay, enter a problem. All right, here's how you do this. Let's go back to the problem. We got 3x plus 3y plus 5z equals 6. That's 3x plus 3y plus 5z equals 6. Now hold shift and hit enter. Okay. And then let's go back. 4x plus 4y plus 4z equals 18. 4x plus 4y plus 4z equals 18. Gosh, with a tool like this, why even learn how to do it? I couldn't help myself. That was my one editorial comment. All right, now finally it's 4x plus 2y plus 1z equals 16. 4x plus 2y plus 1z equals 16, right? Yeah. Now look, here we go. Ready? 3, 2, 1. Hit enter, and it's going to ask you what you want to do. Solve the system of equations, solve using Gaussian elimination, solve by addition or elimination, blah, blah, blah. Just solve the system. One click, 2 seconds later, you're finished. So here are the answers to the question. Just make sure I entered everything right. 3, 3, 5, 6. 4, 4, 4, 18. And 4, 2, 1, 16. Yep. So I guess it's not going to give us decimals, so we'll just write that down. 13/8. So we'll say x equals 13/8. Semicolon, or we can do commas. Well, okay, let's do a semicolon because we're writing x, and then we'll say y equals 53/8. And z equals negative 15/4. Okay, and that is that problem. Now, that is number 15. Okay, and the thing that's bothering me here is I would have thought that these would have resolved to integer solutions, because these are not going to be integers. Just checking my work here before we move on. Let's see, I did anything wrong? 6, 18, 16. No. 3, 3, 5, 4, 4, 4, 4, 2, 1. It's weird. Okay, whatever. Alright, moving on to number 16 next. Alright, final problem. An amphitheater charges $75 for each seat in section A. Let's just bust out that highlighter. Section A is going to be X. Okay. $55 for section B. That's going to be Y. Alright. And $30 for lawn seats. So that's going to be Z. Okay, just make notes. And we'll get to that part about the 3 times as many, okay? So let's just write out what we can. We've got 75x plus 55y plus 30z. And how much money did they make? $870,000. Okay, so quite a bit of money there for a single event, but there are 23,000 z's. So this is non-intuitive, but what you want to do here is write x plus y plus z equals 23,000. Okay, like I said, non-intuitive, that's what you would do, but you just want to say all these different types of seats add up to be 23,000 seats. Now there's a third row, okay, and this requires a little bit of thinking, and that's because of this sentence right here. It says there are 3 times as many seats in section B as section A. Okay, so I want you to think about this for a minute. What is it saying? You got to read it like 5 times before you get what it's saying. It says there are 3 times as many seats in section B as there are in section A. There are 3 times as many seats in section B as there are in section A. So B is equal to 3A. That's how you got to think about it, all right? Now replace those letters with their respective variable assignments. So we said section B was y. So y is equal to 3 times x. All right? So that's your third equation. You write y equals 3x. I know it looks weird. So there's actually another way to write it if you wanted to keep it in this form here. So you could subtract 3x from both sides, right? You could have y minus 3x equals 0. And if you really wanted to put this in standard form, like if you wanted to make this into a matrix, right? And you'd say, well, what's z? Okay, I'll show you. So the negative 3x goes right here. You're going to put negative 3x, and then y is just plus 1y, so plus y, plus 0z. Okay, so here it's 1z, and then it's 0z, and that equals 0. Okay, so you've kind of rewritten this as a third equation. Okay, so here are your coefficients for that second line, 1, 1, 1, and then 23,000. So those are your equations. Now it's fairly simple to transform those equations into a matrix. Remember, we're caring about these coefficients more than anything else. So we're going to grab, oops, I forgot to write the 1 here. So important. And then we'll grab all these coefficients, including that 0 in front of the z. Again, this is a rather difficult problem because half the problem is what I would consider to be non-intuitive. It's just not plainly stated what you're supposed to do, so confusion is anticipated. Luckily, I doubt there will be a question like this on the test, but you never know. All right. So remember that augmented line that's going to end up going there? Okay, so if I wanted to form this into a matrix, here's how it would look. I'd have 75. I'm going to write the columns first because remember the columns are vectors. Negative 3, and then I've got 55. The rows are also vectors, by the way. It's just, and then 1 and 1, and then 30, 1, and 0. And then I've got my augment line, which is where the equal sign used to be, right? And then I've got 870,000, 23,000, and 0. Okay? And then we close those brackets off like this. Now, if you want to solve, right, what you're going to do is type those equations back into Mathway. So Let's type those equations in. We've got 75x plus 55y plus 30z equals 870,000. Did I remember all that correctly? Yep. And then 1x, 1y, 1z, 23,000. 1x plus 1y plus 1z equals 23,000. The least intuitive step, negative 3x plus 1y plus 0z equals 0. Okay? Enter and solve. And there you go. 15,000, 40, or 1,500, 4,500, 17,000. So x equals 1,500, y equals 4,500, and z equals 17,000. Okay, and we're not going to, go to the candle, soaps, hand sanitizer. We're not going to rewrite it. There's no space to write anything. We already converted it. We assigned the variables, so it's clear what you're doing. That would be correct on the test. So we are now finished with number 16, which means we are done with the entire review. Congratulations. Thank you so much for watching. Please make sure to like, subscribe, comment, and hit that notification bell so you're always alerted when I release new videos. Appreciate it.